which we call it scalar or dot product. It's also known as vector 2, and this topic can be very trickish. That's why I have taken my time to tackle this topic.
Please like and subscribe to my channel. Thank you.
So let's start. The scalar and dot product is of two non-zero vectors a, b, and a and b is defined as a dot b is equal to the absolute value of a and the absolute value of b cos theta. But where theta is the angle between the vector a and b. Know that the two vectors must be directed away from the point or directed towards the point. You have to know this. It's either directing away from the point or directing towards the point. So I'm about to show you a diagram that I've drawn figure 1 and figure 2. So watch. Okay, let's consider what I said right now. Let's consider vector a and b. So we're about to draw them. This is the angle between them is theta. You see, this is figure 1. It's pointing, both of the vectors are pointing away from the point, and this one they are pointing to the point. That's figure 2 for you. They are pointing to the point. One, if a and b are parallel, sorry, if a and b are parallel, then theta is equal to 0. Since they are parallel, there's no angle existing between them. So a dot b is equal to the absolute value of a and the absolute value of b. Since cos 0 is 1, so multiply 2, so you can see that there's no angle between them, b and a. This shows that they are parallel. Okay, let's continue. Second, if a and b are perpendicular, that's they meet at 90 degrees, and you all know that cos 90 is what? 0. So let's check what is happening here. Then theta is equal to 90, as I've already said earlier. Cos 90 is equal to 0. So the a dot b is equal to 0. Since the 0 will multiply the absolute values and you get 0. So this is the diagram. The angle between them is 90 degrees. So dot product in terms of components. So in terms of components vector, that's a is equal to x1, y1, and b is equal to x1, x2, y2. So the top x dot x2, y2 here. So the first one x1, x2 plus y1, y2. You understand? Take the x value, multiply them, plus the y values. Multiply the y values too. Also in the Cartesian plane, in the Cartesian form, x1i plus y1j close bracket dot x2i plus y2j close bracket. Multiply the x as you already did earlier. x1, x2 plus y1, y2. Illustrative example. So if a is equal to 2, 1 and b is equal to 3, 2. Find a dot b. The second question, given that m is equal to minus 2, 3, and n is equal to minus 2, 6, find m dot n. So we are tackling the first question. I know that the first question says a dot b, which is equal to 2, 1 dot 3 minus 2, which is equal to 2 times 3 plus 1 times minus 2. And our answer was 4. Let's tackle the second question. M dot n, which you know that m, the vector of m is minus 2, 3 dot minus 2, 6, which you are going to get minus 2 times minus 2 plus 3 times 6, which you are going to get 22. But let's consider another question. If a is equal, this one we are using the what Cartesian plane method. If a is equal to 4i plus 3j and b is equal to minus 5i plus 2j, find a dot b. So a dot b is equal to 4i plus 3j bracket close dot minus 5i plus 2j bracket close. So you know how to do it, x, y, y. So 4 times minus 5 plus 3 times 2, which are getting minus 14. And as I know that whatever I've done right now, you understand, because it's very easy to understand. Okay, let's look at the properties. So we are saying vector a dot a is equal to the absolute value of a squared. They are all these are the properties, so you have to note them. Take note of them. This is the commutative property of dot product. That's a dot b is equal to b dot a. Yes. Also, the third one is a dot bracket b plus c bracket close is equal to a dot b plus a dot c. Now we are adding a scalar. We are multiplying by a scalar. So a scalar k multiplying a dot b should be equal to ka dot b is equal to ka dot kb. You understand? So finding the angle. Sorry, I made mistake there. Finding the angle between two vectors. So given that a and b, we want to find the angle between them. It means that a dot b is equal to the absolute value of a, the absolute value of b, cos theta. So the theta, that's the angle that we want. So cos theta, we can, by change of subject, we can say cos theta, cos theta is equal to a dot b all on absolute value of a, absolute value of b, where theta, as I already said, theta is equal to the angle between the two vectors. Okay. From vector 1, yes, from vector 1, the first vector that was treated, you know that every unit vector, that's a unit carat, you use the carat sign to initiate that, is equal to the vector itself all on the absolute value of that vector, and also applies to b. So do the same thing. So it means that cos theta is equal to a on absolute value of a dot b on absolute value of b, which is equal to a carat dot b carat. Taking note of this, you must take note of this formulas. We'll be using it. So now we are given a question. Find the angle between the two vectors p, which is equal to 3, 1 close, and q is equal to 0, negative 3. So solution, we have drawn it how it looks like. So p. Now you know how the formula goes. It has already been done, so just put the vectors there. You do the scalar So we want to find P dot Q first before we put it inside and solve. So that's what we are doing. And our answer was P dot Q was -3. Also, let's find the absolute value of P. The absolute value of P is equal to the root of the first digit, that's the x digit squared, plus the second digit squared. So when we did it, we had to enq2 the same thing, the absolute value squared, and plus -3 squared. We had 3. So let's move on. Where cos theta, I told you to note that formulas. Now we are using it where cos theta is equal to P dot Q, absolute value of P dot absolute value of Q. So we put our figures there, we get our answer. Cos theta, that's theta is equal to cos inverse of half minus half, which is equal to 120 degree. So question 2, you know that the vector from A to B is 4, 3, and from A to C is 5, 12. Find from the absolute value of A to B, from A to B, and the absolute value of A to C, and the angle between CAB. So solution, that's what you are finding. Now you know that is the root. The absolute value is always the root of the figures inside squared. And we had root of 21, which got 5. For AC2, the same thing. We had root 169, which is equal to 13. Let's move on. So now for the angle, we have to draw the diagram to add position vectors. Let's take our position vector to be A and the other side to be B. To be written soon. Wait for it. Yes, A and B. Let's take it as that. So we know that A dot B is equal to the absolute value of A, the absolute value of B, cos theta. So this is the vector, component vector. So 4, 3 dot 5, 12, which is equal to 5 times 3, the absolute value that we found earlier. That's what you are using here. So don't get confused. Cos theta. So 20 plus 36, which is equal to 65 cos theta. 65, that's 56 is equal to 65 cos theta. So cos theta is equal to 56 on 65, where theta is equal to cos inverse of 56 on 65. And our answer was 30.51 degree. Understand? I believe you understand. To show that two vectors are perpendicular. If two vectors are perpendicular, then A dot B is equal to 0 because cos theta is 0. Show that these two vectors, A is equal to 3, 4, and B is equal to -8, 6 are perpendicular. You know the condition it must satisfy. It must be A dot B should be equal to 0. So that's what I'm writing here right now. If they are perpendicular, then A dot B should be equal to 0. So we are solving for it now. A dot B is equal to 3, 4 dot -8, 6. So you know the normal routine. 3 times -8 plus 4 bracket 6. which is equal to 0. So now we can confirm that these two vectors, since their scalar dot is equal to 0, then they are perpendicular.